Here we go. This should be a fairly quick and easy question, very much like the last one. Again, we're talking about combinations with repeated elements. In this case, we're buying donuts, so something that's maybe interesting to everybody, even though we shouldn't like donuts as much as we do. The reality is we just do. So I grew up in Sandy, Oregon. Joe's Donut Shop in Sandy, Oregon is probably the best donuts that there are. So, they talk about Voodoo Donuts in Portland, not even close to Joe's Donuts in Sandy. So if you're ever going up on Mount Hood, go to Joe's Donuts. They've got all sorts of fritters and maple bars. They're just pretty amazing. So it's probably good that I live far away from there now because I just don't eat donuts so much. But suppose for this problem, there are 20 different types of donuts and you're going to buy 5. Maybe you're going to eat them all 5. So you could say, well, maple bar's my favorite, so I'm going to buy 5 maple bars, and that'd be okay. Or maybe you're going to buy 4 maple bars and 1 apple fritter. And by the way, Joe's Donuts has, they've got like blueberry fritters and cherry fritters, and those are my favorite kind, but you'll have to try those yourself. So in this case, this is a combinations using repeated elements because you can buy more of the same kind if you want, but we're gonna choose a group of 5, and it's sort of like we have 20 to choose from, but there's 20 types. And since we want to choose possibly more than one of the same type, we have to understand that there's really like more than 20 to choose from. So I'm going to use the stars and bars method, and maybe it would make sense to you if I start making bars. Remember, bars create bins. So like this first bin would have a barrier right here, and this would be donut A. And so I could put a star in here, and that means I'm going to buy donut A. Maybe this is donut B, and then donut C and donut D. Well, that'd be a lot of bars to write. To get 20 different bins, I need 19 bars. And again, a bar is just a character that separates into categories. We don't need to start with a bar. The first bar ends at the end of bin A. Well, I'm going to purchase 5. So what I would need is 5 stars somewhere in these bins in between bars. So maybe I do one there. Maybe I really like donut D, and maybe I even like donut A. So essentially, the code for this purchase, and this purchase would be buying 3 of donut D, 1 of C, and 1 of A. There are 19 bars and 5 stars, so really the code would be star bar, bar, star, 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 and then lots of bars until I end up with a total of 19 bars, separating this into 20 bins, 1 each for the type of donut. And then the question is, well, how do I rearrange not 19 bars, but 19, 20, 21, 22, 23, 24 characters? So I arrange 24 characters 24 factorial ways. That's just the total number of items. But that's not the number of ways to do this, because that would be 24 unique characters. We only actually have 2 different types. We've got stars and bars. So it's the Mississippi problem again, where we have to divide by the factorial of the number of bars and the number of stars. And you can see if we were to use the formula on this problem, it would be there's 20 types, so that'd be our N, plus I'm choosing 5 for my groups, minus 1, C, 5 total. So visually, if you look at the stars and bars method, it turns into the Mississippi problem, and this is your calculation for the number of ways to buy 5 donuts if there are 20 types and repetition is allowed. So hopefully that helps out. You're getting some more practice. The next problem I do is going to be from the book, and it's a little bit more complicated, but well, actually there's 2 more that I'm going to do. I'll do another one that's an intermediate one, and then the one in the book is pretty complicated. And I've got a THQ that's like the tricky one. But tricky problems are fun, right? So hope you enjoyed that and you're having fun staying at home watching videos. It's definitely not as good as being face to face, but again, here we are and I'm grateful. Life is good. Love you all and we'll see you soon.